Hi everyone, welcome to my channel. Today we are going to discuss about a much discussed topic in our times, which is artificial intelligence. We are not just going to discuss a general idea about what is artificial intelligence is all about. We are specifically and very particularly going to discuss about what artificial intelligence can do in piping design and what it cannot do in piping design. Without wasting your time, let's begin. Before jumping into the topic, let's try to understand what is artificial intelligence in a simple term. Artificial intelligence is a technology that can analyze data like human intelligence does, using complex algorithms, programs, codes, and logics in order to produce a result which is similar to the result produced by human cognitive process. Basically, artificial intelligence is a technology is going to minimize the human effort in whichever field it is going to come. But today we are specifically going to discuss about what it can do in piping design, what it cannot do in piping design, because it's important to have a clarity on how it is going to impact the piping design industries. We are not sure about what is going to be the actual impact in future. However, based on some presumptions and assumptions from my perspective, I am going to put there are certain things that artificial intelligence can do and certain things that it cannot do. So let me start listing out with those things that artificial intelligence cannot do, and then I will summarize what it can do. Let me start from the first point it cannot do. Number one, AI cannot do plot plan design. Why it cannot do plot plan design? Because plot plan designing is not a linear process. It's a more complex process where you will have to take decisions and engineering requirements finalizations, considering certain parameters based on time to time with respect to assumptions. It's a complex process of taking multiple decisions in various levels, especially financial factor, environmental factor, national security and statutory requirements and international codes. Everything is into it. So designing a plot plan is something not like putting couple of inputs and get the output. So since it is a more complex process, AI cannot do plot plan designing. Before moving to the next point, let me take few seconds to brief about Pymedaca design courses. Pymedaca design courses are basically a skill-based design courses. You take one design courses, you will get one skills. You take two courses, you will get two piping design skills. You take three courses, you will get three piping design skills. These are primary piping design skills required for all piping design engineers. Basically, I only have three courses, one for P&ID, supports and routing. These three skills are considered to be the most important and most primary requirement for any piping design jobs. Most of the people who have taken this course were able to clear the interviews and were able to increase their salary more than 30 to 40% than their current salary. These courses not only teach you the theories, it will also tell you with schematic and pictorial graphical representation to show you the engineering requirements, philosophies and parameters to finalize and the decisions that you have to take as a design engineer. That is the intent of this course. That is one of the major success of this course actually. Basically, these courses are intended to develop you the job skills that is required in the real job. So please go through the description of this course. You will also find the preview of the course video, so that will give you an idea about what is the intent of the course and the content of the course. You can always reach to me in my WhatsApp number that is already provided in the details of this course actually. So I'll be able to clarify you in case if you have any doubts about the course. Moreover, currently I am going to launch 30% flat offer for all three courses actually. Please avail this offer in order to improve your knowledge in piping design engineering. Number two, AI cannot do 3D modeling. Now immediately you can jump on me saying that no, there are softwares that can do 3D model automatically. But developing a 3D model is similar to developing plot plan. It's a very complex process. You will have to see the spacing. You will have to take some assumptions. You will have to see accessibility, maintenance. You will have to see the cost. So there are multiple factors into it. It's not about assuming certain parameters and directly completing the modeling. It doesn't work in that way. Indeed, 3D modeling is a biggest activity. I mean, it inclusive of all designing activities as well. So generally, 3D modeling takes a lot of time. There are projects you will have to work for 3 years. There are projects you will be working for 3 months. So AI cannot do these complex decisions because it involves lots of inputs from various disciplines, various times, and various expertise. That's one of the reasons why AI cannot do 3D modeling. Now let's go to the third point, 2D drafting. AI cannot do 2D drafting. In this world, most of the 2D drafting scopes were being replaced with the 3D modeling. However, there were 40% of industries still holds the 2D drafting requirements. You know why? Because of the cost from going to 2D to 3D. Even the top companies in the world are still not have migrated 100% to the 3D model because of the cost. The plants which were built 30 years, 40 years ago, they still have the drawings in 2D. So it's not possible to convert all these drawings to a 3D to make it so intelligent, because that cost who is going to bear? So 2D drafting cannot be done by AI. Number 4, it cannot finalize pipe routing. Why it cannot finalize pipe routing? Because pipe routing finalization is also a complex process of taking decisions and considering certain parameters and taking certain references from client specification, international requirements. There are many things are involved. And based on the optimization, based on the space available, based on the cost, and you will have to do many things in the routing. You need to have a different approach in different situations. For lines which has an insulation, the lines which has a vibration, the lines which has a very thin wall, you will have to see different requirements in order to finalize that routing. That's why I strongly believe pipe routing cannot be done by AI. Number 5, AI cannot do optimization. Why it cannot do optimization? First of all, we have to have a strong understanding about what is optimization is all about. There are various aspects of optimization. And the first thing is grouping of lines, grouping of equipments, and grouping of lines with respect to various parameters like temperature, pressure, utilities, and process lines. There are various factors are there. So optimizations are basically done in order to save the space, materials, cost. So these things, it's a very complex process. It cannot be done by AI. Number 6, AI cannot do 3D model review. Why it cannot do? Generally, in most of the projects, you will be doing 30% 3D model review, 60% 3D model review, and then the 90% 3D model review. And if required, you will be doing during the AFC as well. So these are done in different stages. Stages, it starts at the very beginning of the design engineering, and stages after the vendor input, and stages after finalizing everything in the design. So it keeps on varying. So still, the assumptions considered in the 30% review still has to be in the 60% review, provided there are little bit improvement in the design. So here the assumption varies, and there are cases that you keep in hold, there are cases you proceed. So it varies time to time. So it cannot be done by AI. 7th is AI cannot do support selections or support type selections. Why it cannot do? Because it's a kind of optimization you do based on cost and material availability. So once again, it's a complex process. It's a decision of an engineer whether to go with the trunnion or whether to go with the shoe. It cannot be programmed. So it is a cost-effective design that is produced by the designer. So these things cannot be done by AI. 8th is analyzing vendor input and assessing the impact in your design. This is not an easy task. You will have to verify the vendor inputs, whether it could be a valve or equipment or anything. You will have to go through the vendor input. There are various dimensions of it, various aspects of it, various parameters are there. One parameter might impact your dimension, and another parameter might impact your civil foundation, and the third parameter might impact your supports. So you will have to see many things in order to see the impact in your design, so which cannot be automated. That's why it cannot be done by AI. Ninth is, AI cannot do pipe rack design finalization. Why it cannot do? Once again, pipe rack design finalization is not a linear process. You will have to do many things in order to arrive the right pipe rack, right elevations, right number of tires. So once again, it's a complex process. You will have to finalize the preliminary routing of each and every line that needs to be carried in the pipe rack. It's not so easy to do it. Only then you will be able to finalize the pipe rack itself. Though it is done in different stages with the different assumptions actually, you will have to go through these assumed parameters. So this cannot be automated because there are lots of human interferences is required. And the last but not the least is nozzle orientation. Why nozzle orientation cannot be done by AI is nozzle orientation, it's one of the most important activity in piping design. If anything goes wrong in nozzle orientation, it will directly impact the equipment. So you will have to see each and every nozzle whether it is rightly placed, and it is placed in such a way that it is accessible. If it is not accessible, what is the mitigation to be taken? So there are many assumptions, many evaluations, many requirements like client requirements and international standards and some specifications and safety requirements. Everything needs to be assessed before finalizing the nozzle orientation, because when you finalize a nozzle orientation, that is where you're going to connect your piping. So it's so important. So it cannot be automated, because if you automate it, you cannot rely on it. What if something goes wrong and if the equipment gets damaged, and it will be a huge disaster in the plant. So it cannot be done by AI. Now comes the most interesting part of this video, which is what AI can do in piping design. Because we must agree that AI is definitely going to replace some kind of an human effort. So we should be prepared rather than worrying about it. So let me just list out what AI can do in piping design according to my perceptions and understanding about the industries. However, what I'm going to list down, it's not going to be an easiest task even for an AI companies to implement, because it needs lots of improvement from the current level of software what we are using in our industries. Only then we will be able to meet these requirements. Otherwise, definitely what I'm going to list down, it's also not going to be done by AI. What AI can do? Number one, preliminary equipment arrangement can be done by AI. This will help you to finalize the unit plot plan. However, the output you receive from the AI, this is my expectation in future, we are not using anywhere in our current times now. So if AI produces a preliminary equipment arrangement, still you will have to look into the various aspects of this equipment placements, like its elevation, its accessibility, its safety requirements and client requirements. Everything needs to be checked. However, it can be a little bit helpful in order to finalize the unit plot plan, not the whole plot plan. Number two, AI can produce some warnings or alarms for designers while doing 3D modeling. This will help them to finalize the 3D modeling so quickly than going for each and every simple requirements. Definitely, you will have to go through lots of client specifications and general requirements and everything. At least the standard requirements can be fed into the system in order to give a warnings or alarm. Likewise, a minimum spacings or minimum accessibilities or maintenance requirement, constructability, those things, so that AI will give you a warning whether the space is enough for in that particular location or not. Third point, AI can help you with a preliminary routing and different options. It can give you a preliminary routing but not the final routing, because as I said, to finalize the routing, you will have to go through lots of parameters, assessments and evaluations. But however, AI can just give you a preliminary routing from the starting point to the end point, and also it can give you an options of different arrangements for any control valve systems or any other piping arrangements that you have to have multiple valves or bypass lines and everything. So this option will ease the 3D designers in order to complete the model. This is my expectation for the future. Currently, we don't have any such options available in any of the softwares. But however, if AI dominates the softwares, definitely these options are expected. This will reduce the efforts that designer puts in order to develop the 3D model. And the fourth is model completion rate. What is model completion rate? Now, we are doing a 3D modeling with respect to the lines shown in the P&ID. So there are some lines that you might miss, so you will have to manually verify. So if AI can help us in order to identify those lines, so we will be able to know that how much 3D modeling is done with respect to the P&ID, and so that what are the minimum number of lines are missed and which portion of the lines are not modeled. So it's basically a comparison from the P&ID and directly to the 3D model. Number 5 is AI can help us with rough cost estimate. Because a rough cost estimate needs a couple of inputs. It can be already fed in the 3D model, and if AI can generate the inputs based on the 3D model, and it will be much helpful because this will save a lot of time in order to generate the estimates. AI can help us to avoid the manual MTO check, because even nowadays most of the companies are doing the MTO check manually. If AI has any particular softwares or utilities that can help us to do the MTO checking conveniently based on different project types. Greenfield, you need to have a separate software, and it needs to have the supporting elements to cover the brownfield requirements, like checking with respect to the through 2D drawings and 3D models. So this flexibility is required. If you produce a software that is only help you for the greenfield project, definitely it will not have a bigger market. So basically you need to have the technology that can support for all areas of the industries. 7th is pipe spec creation. Definitely pipe spec creations can be automated using AI, because pipe spec creations, yes, it's a complex process, but however, if you can develop a program in such a way that all fitting details, all requirements of the chemicals and MOCs, temperature, pressures and standard requirements are fed in, definitely it is much easier. 8th, it's basically my expectation for the future to include the thermal expansion impact in the 3D modeling software itself, so that the designer, the piping designer, when he models the 3D model itself will come to know the impact of the thermal expansion of the lines, and accordingly he'll be able to arrange the lines. So this will help the stress analysis engineer and as well as the layout engineer and as well as the modeling, and also to complete the project within a given time. 9th is conversion of a 3D modeling software, either from any piping softwares like E3D or SP3D directly into stress models without any error. Nowadays we do have a provision, but however there are lots of errors, there are lots of compatibility issues are there. But if AI can replace this compatibility, so that you will only have to do one modeling, you don't have to produce another modeling in the stress softwares. This will minimize a lot of time, because in stress analysis most of your time is about the modeling and how you model it. If AI can produce an intelligence in order to convert that directly the 3D model from the piping softwares to the stress softwares, then it will help us to save a lot of time. And the last but not least, I strongly presume that AI will be able to assess the standard accessibility and escape routes requirements in the layouts or in the 3D model. Because if you fit some minimum informations, maybe you will have to look into these informations or requirements every time. This will help the 3D designer in order to finalize the model. So these are the requirements that I would see that AI is going to replace in future. However, I don't see that AI is going to have impact the piping designing in a level that we are thinking. Definitely the impact of AI in piping design is very, very low. I would strongly say that in the coming years actually. However, we will have to see the evaluation of the software and how the AI is going to emerge in the near future. I will meet you in another fantastic video. Until then, bye from Subhash Chandran.